mentioned earlier, the resole controller is the brains to our system, and with it comes some very neat little devices which will enable you to check it in the field, both during installation and commissioning, and also as a post-service benefit as well. The cold sensor here is located and already in situ, so we generally won't need to take that or change that. What I've done here today, just to show you what it's going to look like with both sensors in, I've got a small sensor which we provide with this, a hot sensor which we provide with our solar control tester. And I'll plug that in, and that will simulate. Now we're going to start to hook it up, and we're going to simulate a little bit about the operating conditions of what it looks like when it's operating. You need 240 volts to it, so again, just be aware this is you shouldn't take any of these covers off here. If you've got 240 volts floating around, just leave that on at this point in time, and don't do this in the open if it's raining. Obviously, on the side of the tank, it's okay to remove that, but just be very careful if there's a lot of water around or it's raining or so forth like that. So what we'll do is we'll plug this device into our power supply, 240 volt power supply, and what we've got now is the digital display in here lights up. Takes a minute or two to set, and what it's going to provide us is a digital display of the temperature right at the moment at this particular point in time. Now, we've got a lot of information about this device in our documents that we provide you, but there's a lot more on our website if you want to come and visit it and learn a little bit more about it. But I won't go into too much detail today other than a very quick summary about how it works and how we can test it. You've got a thing called TC and TS. Now, these two items indicate temperature in the controller and temperature in the stored or storage tank. And right at the moment, you can see that we've both got, which is what you would expect because both the sensors are sitting out here in the open. We've got 25.8 degrees on both of them. Obviously, it's measuring exactly the same temperature on the bench here in front of me today. We want to now go through this and see how we can run it to make sure it is run. Now, say today you've just finished off your job, the sun's a bit dull out there now, there's a good chance this is not going to operate. So before you leave though, it's a great idea to be able to test this and make sure that all the parameters that we've set in the factory are working and you can see them all operating. So, as I said before, these are just variable temperature resistors. But what we're going to do with our little box here is simulate the varying changes of those resistors to affect the same outcome by just turning this little knob. And now I'm going to connect it up. We've got this device provides you a little connector for the old style system where they just go straight on and connect into here. Keeping in mind that the red is always to the far left-hand side when you need to connect this on. But for this one is one of our new controllers, so we can remove this, take that off. We're going to unplug this here, the little quick snap connection. This is the device that's now obviously connected to our sensors, and we're going to disconnect that. And now we're using only the side that goes into our resole controller. So we're going to plug that in there. We're going to plug that in there like that. You can see there's a little snap-on connection at the back there, and that allows us now to plug that in. So what we're doing is we're taking out our two sensors, our hot and our cold sensor out of operation altogether. And instead, what we've done is we've put this device in, which inside is a whole heap of resistors, and will do the same job for us. So I'll put that up there so you can see it. And we're now looking at, we've got it in the solar stop position. So you can see the temperature in the collector is saying it's 20 degrees. And the temperature in the stored tank is 63. Now keep in mind before, remember when we had these two actually connected, they both read 25 degrees. So all of a sudden now we are simulating the variables which the controller is looking at and trying to ensure it operates under. So this goes through all the parameters that we are looking at here in our system. We've got freeze control, solar stop, solar run, tank high temperature, sensor open circuit and sensor short circuit. So I'll provide you a little bit of information about what it looks like when you get these conditions applied to the system. All right, so let's go into freeze protection. First of all, what does a freeze protection do? Now, it does have limited control over circulating water up hot water up to the collectors. And in mild areas where you might get a small temperature, right down to about 0 degrees or 1 degree, this will work well. But please don't be fooled by the fact that this will work in really severe snow conditions or freeze conditions. There won't be enough energy in there to save that. You've got to have proper heat exchange type systems like our thermosiphon system that we've shown on a similar video before. So I'm going to put that into the freeze protection device. In a minute, the pump will turn on and start running. What you're seeing now is that the temperature in the collector is at -4 degrees. The tank storage temperature is 19 degrees. So that's simulating that operation, and we can see, well, that's running. That's what we wanted to see, okay? Now, -4 degrees is going to be a lot of trouble if that gets out there in real life, but this will be able to handle that and provide a level of protection. For further protection, there are devices which you can put on there, but I would recommend that you talk to us about it if you're in a severe frost area or severe freezing area. Okay, so we're going to now turn it off. Okay, shut down. Again, it goes back to sensing the temperature in the collector is 20 degrees and the temperature in the stored cylinder is 63. Now, when you've got those temperatures, you don't want to be running your water or your system. You don't want to be taking your hot water from your tank up to your collector, because your collector is normally a heat source. And in these conditions, if it was to run, it would be a heat sink. So you just lose your energy that you've taken all day to store. So you don't want that to run. Similarly, in the freeze protection device, the only reason that's running is to prevent the freezing in the collectors and keep the warm water running through the collector and prevent freezing. So it's important to note you will dump energy in that mode. Okay, now we're going to put it into the solar run mode. Now this just simulates it as it was running. Great idea at the end of the day when you finish your installation, you want to check that everything's working all right. You've opened up your air bleed valve, you checked all your fittings, you made sure everything's all right, you've cleaned up your collector glass, you've connected your power to your sub-circuit and your booster, you maybe got that turned on to give somebody hot water that night straight away, but you just don't have enough energy in the collectors to see if it's working properly, and you want to check before you leave. Okay, so I'm going to turn that on now. Okay, so it takes a minute to sense all this. All right, so you can hear it's running. Now, look, it's running dry, so obviously it's probably not going to be sounding like that with water in it. We've got the temperature in the collector at 63 degrees, and the temperature in the storage tank at 21. So it's saying, yeah, look, I've got plenty of energy up there in the collector. Turn it on. Make sure you suck all this energy out of the old sun sponge up there and get it back into the stored water. All right, so eventually you're running this and you say, okay, well, will it cut out at high temperature? The sensor, which is located in the bottom of the tank, senses the stored water, and at 70 degrees C, which we've preset, it will turn off. So I'm going to turn that to that. Okay, so it's saying now that the temperature in the collector is 97 degrees, so plenty of so-called energy up there. But hey, the temperature in the stored water is 79 degrees. So there is amply, again, more than enough energy in the tank according to this, and it switched itself off. Now we have a differential. A differential controller allows it to turn on and turn off, only at preset differentials between them. So it turns on when there's a 10-degree differential between the collector's temperature and the stored water temperature. So for argument's sakes, if we had 30 degrees in the stored water and we had 40 degrees or 45 degrees in the collector, it will turn on. At 40 degrees, it will turn on. And then it turns off when there's a 1-degree differential between the two. So again, keeping in mind now our temperature in our stored water has gone up to 40 degrees. By the time it gets to 39, it's still saying the collector's 40 degrees, it will then turn off. And that's to stop it hunting it. Because what you're doing is you're pushing water up there and you're not getting any more energy out of your collector, and you don't want to lose energy. So we've got now the high tank temperature has turned it off. It says, look, you've reached 79, your upper limit. We don't want to go any more now, because that's starting to get to the high end temperatures that become a bit of a nuisance. Now, two other items it shows, and this is the earlier discussion about dogs and animals biting up and chewing up these things, or your builder that just had his bricky team out there at put a chopped a brick and cut this in two. We might have a closed circuit or a short circuit, should I say. That's where two wires which are insulated and supposed to be separated join each other, and that's called a short circuit, or it's completely cut and it's an open circuit. So this device can tell that. So we're going to put it now into the sensor open circuit, and now it's gone, shows 888 in both the TC and TS. What we're doing is we're simulating in both conditions an open circuit. Okay, so it's a positive 888. Now this could as easily occur if one or the other were to open circuit. So you might have a normal reading on one, but the other one says 888. Well, that would indicate maybe that one's open circuit and the other one isn't. Okay, and that could be because somebody's forgot to connect this in the bottom, and the hot sensor hasn't been connected up. That's an obvious one. So this, as I said, is the sensor open circuit. So it's all positive 888s. You can see the little flashing light. That's indicating a fault, and there's a little spanner located in there as well, just to provide indications you need servicemen. All right, so now we're going to show you what it looks like when it goes into a short circuit. Again, that's when the wires have been cut and joined together, when it's been short circuited together, and that means that the electrical current is not going through the sensor. So now it shows 888 again, but this time a negative 888. So that runs you through everything associated with the device, which you can do with this. I can show you a couple of other little things just to give you some indication of what it looks like when you've got one open and one normal. So that's quite easy with this here. So let me show you this. I'll unplug this again, plug our system back in. Okay, so it goes through the startup phase, and again it goes back to the TC and TS, which is now measuring these two items here. These are the sensors, so this is no longer in play. Take that way out of sight. Now what I'll show you now is what happens when you do have a genuine open circuit, which it'll indicate as soon as I pull this hot sensor out. There we go, got it out. Bit of a tough one. Now in a minute, TC, you see the TC goes to 888, it's positive, little light starts flashing, so that'll give you an indication where, and it's still measuring the stored water temperature at 25.9 degrees, so nothing's changed there. So these little devices are quite good just to check a couple of conditions of the system to make sure they're all operating. We factory set them. We have a range of settings which we provide in the instruction manual, which is provided on the sheet in front of you. It gives you all the settings based on an open circuit system, which is what this system is, and it provides that information as to what we've set them for. Now we've done that deliberately. That's a part of our arrangements when we submit our systems for modelling with the Clean Energy Regulator, and they're the parameters which we are passed under. So please leave them under those conditions. We know that they work and operate in the best interest of the system and how it works. If you do need to understand anything or want to vary something and you've got a reason to do so, please let us know and talk to us first before you do it. I'll give you a similar example. I was asked today by one of our salespeople about a customer that said, shouldn't we set the differential to 30 degrees? The differential on now is at 10 degrees. If you were to do that, a differential on at 30 degrees, it meant that the collector would have to be so far above the tank stored water temperature before it turned on, and that's just a waste of energy. You want to be able to get as much energy into the system as possible. So we've set it at the optimum condition of having it on at 10 degrees and backing all the way down to 1 before it turns off. So that means you're getting any energy in there that you can, and that's better than getting nothing at all. We can change the parameters in this system by altering some of the system settings. We don't think normally that would be a requirement for customers to get involved in. Service people may want to do that for reasons, again, that would be best consulted with us first of all. If you do buy one of these controllers from us just as a spare part, we will have them set out pre-factory set to the conditions of our system. for your own use, for own reasons, not connected to our system. Obviously, we can run through how to set them up if you want to use them for some other device. But for our systems and our solar water heater systems, please maintain the settings that we've indicated in our service and installation instructions sheet. These devices are a spare part within our service range. We don't issue them with the PM602 systems, so if you do need one, and I would recommend that you grab one of these at your earliest convenience. We have plenty in stock. Just contact any of our sales officers and ask for the Envirosun Solar Controller Test Kit. It's used for the AS systems. It comes with the test box as well as the adapter for the old hardwired systems, and it's got a hot sensor as well. So please, it's a good investment. Make sure that you grab one as soon as possible. Thank you very much, and if there's anything you'd like to contact us about or talk to us about, please feel free to come to us, email us through our website, or myself direct, or call us on in our Perth office at any time. Thank you.